Question number 7. So question number 7 wants us to plot the points of an absolute value function. Alright? So again, we know absolute values is when something has these two lines right here. Alright? Those lines means absolute values. Okay? So your absolute value would be either a V shape or an upside down V shape. Okay? Whenever the coefficient in front, whenever the number in front is positive, so again, whenever the number in front is positive, or whenever it has a positive leading number, all right, it's a V shape. Whenever the number in front is negative, all right, it has a upside down V, okay? So this is when it has a negative leading coefficient, okay? So what we're going to do for this question, guys, is that we're going to try to graph it, okay? So when you're graphing this, you always need to graph what we call the vertex first, okay? So to get your vertex, you look at the number inside of the absolute value, and you do the opposite of that sign. Opposite of a negative 5 is a positive 5. You look at the number to the right of the absolute value, all right, and you do the opposite of that number, or rather the same as that number, not the opposite. You do the same as that number. So my vertex is 5, negative 2. So now I'm going to graph that. So I'm going to graph positive 5 on the x-axis and down 2 times on the y. So that's my point. So now I need to find my other points to make my graph, all right? So what you're going to do is that we're going to plug in x values to the left and to the right of our point, okay, so that we can find the y values that go with them. So what I would do is that I would rewrite this equation, 3 absolute value. I'm going to replace the x with the x value to the right. So to the right of positive 5 would be positive 4. So I'm going to plug in parentheses 4 minus 5 minus 2. Now I'm going to calculate. So the 3 I would bring down because, again, I'm going to calculate inside first. 4 take away 5 is negative 1. Bring down the negative 2. Okay. Now we're going to apply the absolute value. Absolute value makes this number turn into a positive. So we have 3 and then a positive 1. Okay. Now we're going to multiply by 3. 3 times 1 is 3. 3 take away 2 is 1. So that means that coordinate was when x was 4, the y was 1. So when x was 4, all right, so when x was 4, the y was positive 1. Okay? Because the absolute value is symmetric about its vertex, when you plug in 6, which is to the right of 5, you should also get 1. All right? Let me prove that to you. So if I have 3 absolute value, instead of x, I replace it with 6. Minus 5, absolute value, minus 2. We calculate on the inside first, and we will get 1. Bring down the negative 2. Absolute value makes this number turn into a positive, or stay a positive in this case. Right? 3 times 1, 3. 3 take away 2, 1. So as I said, when you plugged in that 6, you should get a similar point as here. Alright? So now we will plug in another set of numbers to the left of this point, which would be 3. Alright, so now I'm going to plug in 3. So I'd have 3 absolute value, parentheses, replace x with 3, minus 5 absolute value, minus 2. So then we bring this down. 3 take away 5 is negative 2. Bring this down. Alright, so then the absolute value makes this number turn into a positive. So then now I have 3 multiplied by 2 minus 2. 3 times 2 is 6. 6 minus 2 is 4. So this coordinate would be 3, 4. So when x was 3, the y was 4. So that means when we plugged in 7, we would also get 4. So if you realize we're going up 2 and then to the left or to the right. So here I will go up 1, 2 to the left once. So the next point would be here. Up 2 to the right once. Next point would be here. Up 2 left once. Up 2 right once. Up 2 left once. Up 2 right once. Alright? And then all you gotta do now is connect all your lines together. So you click done plotting, and then you use the pencil, and then you connect all your lines together, all right, as best as you can. So again, as best as you can, okay? So let's try the next one, okay? So the next one, we always graph the vertex first, okay? And to get the vertex, you do the opposite of this number, same as this number, all right? So positive 2. So now we graph it, negative 1 for the x, positive 2 for the y, all right? So now I'm going to plug in points to the left, so x values to the left and then to the right. Negative 2 is to the left, so I would have absolute value, or rather negative absolute value because it's a negative sign right here. Absolute value, replace x with parentheses what? Negative 2, right? Then plus 1, absolute value, right? Plus 2. So the negative in front of here is technically a negative 1. You bring that down, all right? So then negative 2 plus 1 is negative 1. And then bring down the positive 2. The absolute value makes this turn into a positive number. So we bring this down again. This turns to positive 1. Then plus 2. Distribute. And then you will get negative 1 plus 2, which is 1. So that means that when x was negative 2, y was 1. So when x was negative 2, the y was positive 1. Right? So that means that when x was 0, y would be 1. Because again, when you're on the y-axis to the right of negative 1, you'd be at 0. Okay? So if you look, we went down once, left once. So down once, left once, 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 down once, left once. And then here, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, right, and then so forth, going all the way down, right, up until you get to the next one. So right here, then, I'm sorry, my eyes are not so good, here, 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 down once, right once, here, okay? So then all you gotta do now is click done plotting, and then connect all your lines together. And you see how we have an upside down V, guys? The reason we have an upside down V is because the number in front is negative. So again, because the number in front is negative, that is why we have an upside down V. So again, just like